Nowadays, pixel art is a popular art style chosen by indie developers or even large studios. It was established as a response to the hardware limits of consoles in the past. Its comeback in the late 2000s was partially driven by nostalgia and partially because smaller studios were no longer able to compete with major players in the realistic graphic field. What does working with pixel art look like from the perspective of an indie developer in 2024? What complications must be considered? I will give you answers to that based on examples from the game I'm currently working on and my previous game. First and foremost, it's necessary to consider all the possible resolutions and aspect ratios that modern screens use. Taking a look at Steam's hardware survey is a good starting point to get a good grasp of what are the most popular choices for gamers these days. It's crucial for 2D games to choose what aspect ratio they will use early on. I will explain why in a moment. 1080p monitors are still the most popular, but 1440p is getting more common. Both resolutions have a 16:9 aspect ratio. Of course, it depends on the type of game, but for me, I think it's a good choice as the basis for consideration. When you look at the screenshot from Pumpkin Man, you can see individual pixels, simply because the scene is scaled up, so each pixel in the sprites takes more than one pixel on your screen. How many? It depends on your device's resolution. This video is 1080p, so if it also happens to be your display resolution, and if you are watching on full screen, that's how the same scene would look like if a single pixel took exactly a single pixel on the screen. This small scene resolution is something I would call the game's native resolution. I also came across a standard resolution term for this. For the game I'm working on, it's 640 by 320 pixels. The caveat is that when scaling a game from this native resolution to bigger ones, it can only be scaled by factors matching the native resolution. Otherwise, the game will have a pixels of different sizes on the screen, and that's why it's important to choose the correct aspect ratio early on. For the native resolution I've chosen, this is the list of possible bigger resolutions I can scale the game to without having to stretch pixels. But when looking at Steam's survey, we can see that some quite popular resolutions aren't covered by this list. First, let's look at this one. It's not quite as problematic as at least one dimension matches one from our list, so it's possible to scale the scene from the native resolution to 1080p and center it. We are left with those black bars above and below the scene. This is a pattern you will see a lot in 2D games, simply because developers have to consider all possible resolutions, in the way that the whole screen is filled with the game content, which would require creating this content where most of the players, using most standard resolutions, wouldn't even see it. This is super obvious when you think about widescreens. It's different for fully 3D games, where all available space can be filled by simply rendering more stuff, for example by making a field of view larger. More problematic is for example this resolution, in the past commonly used in laptops. Here, so-called letterbox scaling results in black space all around the scene, which for me is quite annoying. Here two possible solutions exist. One is to allow player to change the scaling option to one that allows pixel of uneven sizes, because it's possible that you wouldn't even notice that without looking for it. The second option is to have a bit bigger native resolution chosen for the game and simply render more stuff. For most common resolutions, this additional content will be cropped out, and for non-standard ones, it can be used to fill the blank space. It won't work for each resolution, for example filling the whole widescreen would require a lot of additional content. Also, it requires more work on the developer side, to check each scene in different aspect ratio, to make sure no garbage is showing up in the extra content. For some games, it also can be just not feasible gameplay-wise, as some players can have an unfair advantage simply because they see more stuff on screen, but for my game it's a solution I'm considering but haven't implemented yet. But how, from technical point of view, do you go about implementing letterbox scaling? The easiest approach is to create texture or render target in memory with the size of the game's native resolution. The whole scene is being rendered into this texture, and only when the whole scene is ready, this texture is being rendered onto the center of the screen, with the biggest possible resolution from the list. All pixels are scaled evenly, as each of these resolutions is a product of the native resolution. By scaling the scene only once, it's possible to avoid some graphical glitches that can be present if you were not careful enough. It also has this nice feature that in the game world coordinates always map one-to-one to a number of pixels on the screen. For example, for my game, one in-game unit or meter is always 24 pixels. There is one more trick that I use. Even though the native resolution for my game is 640 by 320 pixels, the texture I'm rendering it into is 2 times bigger, so each pixel is 2 by 2 already at render time. This still has all the nice features of rendering in native resolution, but unlocks having sub-pixel details if needed. It's easiest to explain this in the graphical editor. If you look at this sprite and try to rotate it in its original size, it ends up all messed up. There are not enough pixels to preserve all the details. But if the same sprite was first scaled by 2 and only then rotated, more details will be preserved. I know that some of the pixel art purists are bothered by this because it's not something you could do back in the day. But for me, it's simply better to have more than fewer options. Yet for sure it's not an effect you want to overuse. Here's an example of this in Pumpkinman, where particles, even though they are square, are freely rotating. Another thing I've learned the hard way when working on Pumpkinman is to implement everything I was talking about, so-called resolution independence, as early as possible, together with a window resolution selector. For a long time I was making the game in fixed 720p. When I got to implement resolution changing, I had to rewrite a lot of rendering code, as it was based on too many wrong assumptions. Having independent resolution from the start makes testing each new rendering feature more future-proof. There is still one piece missing in this whole story, namely text rendering and more broadly user interface rendering. Games often, for text rendering, use something called sprite fonts. These are simply images with all the characters which can be used in the text. Using sprite fonts has the advantage that rendering them is super fast and works the same way as rendering every other sprite. If the given game is going for the fully pixel art look, so fonts are also pixel art, then there's no need to change anything in the rendering code. Simply render the scene, then text over it and scale everything up. If the font was pixelated to begin with, it would scale up nicely with the whole scene. Of course, this won't work for non-pixel art fonts, as they will appear blurry after being scaled. Also, being strict about this limits the amount of the text you can put on screen, which can be problematic for story-driven games. For my game, I'm planning to use a more high-resolution font. The solution here is to render all text and interface on top of already scaled scene. This also has the advantage that I have all the dev tools embedded into the game itself, so having more resolution to draw dev tools simply means I have more space to work with. One thing to consider is that the bigger the display resolution player has, the smaller the text will appear on it. This is exactly how it works in Pumpkinman. It isn't too bad, but for my new game I want to do better. There are two ways to combat this. First, it's possible to have sprite font in very high resolution and scale it down as needed. I haven't really tested this solution much, but I felt it can result in weird artifacts, but I may be mistaken. The solution I'm using right now is a bit more memory hungry but safer. I simply have a couple of sprite fonts, and which one is used at the moment is decided based on the current screen resolution. It isn't fully dynamic but completely functional. That's all for today's video. Thanks for watching, subscribe for more and leave a comment if you have any questions. Have a nice day and I will be back with more updates in 2 weeks.